Can a half-wave rectifier be made with just one diode and no resistor? So if you see, this is a basic half-wave rectifier circuit. This is the diode, PN junction diode, input signal, output we are taking across this resistor R. So if input is alternating current AC signal, this is the positive half cycle and this is the negative half cycle. The output we get is a pulsating DC, that is negative half cycles are blocked or removed and only positive half cycles are presented in the output. If it is an ideal diode, then this positive half cycle in the input and the positive half cycle in the output are exactly identical. Whereas if it is a practical diode with a drop of VD on or cut-in voltage V gamma across it, then also output for positive peak follows input, but with a drop of VD on, one diode drop. Can we draw the circuit, or can we achieve half-wave rectifier operation with this circuit, wherein everything is same? The load resistor RL or the resistor R, which is connected to the cathode of the diode, is removed. If you see, this circuit does not work as a half-wave rectifier. Many people think that the rectification action is by the PN junction diode, because this is the element which acts as a switch, on switch or a short circuit during the positive half cycle, half switch or a open circuit during the negative half cycle, so that it is blocked. But if you observe, during the negative half cycle we get zero output voltage, but whenever this resistor is removed, we cannot get 0 volts here. The reason is, if you see Ohm's law, which states that V is equal to I into R, so 0 current flowing through a finite resistance gives 0 voltage across it. Whenever the diode is off, that is open circuit, the current through this resistor is 0, so that voltage across this resistor will be 0. But now in this figure, without this resistor, during the negative half cycle, when this diode is off, open circuit, we cannot say that the voltage across this terminal with respect to this terminal, which are open now, as 0. We can say that this voltage is 0 only when 0 current flows through some resistor R, so that 0 into R is 0, we can tell as 0. But if there is no resistance, the voltage at this point with respect to this point, we cannot tell as 0. Why? Because it is an open circuit. We cannot tell the voltage as 0. We cannot tell the drop as 0. If they are short circuited, or if they are connected by a resistor R with current 0 in it, then only we can say that the voltage is 0. So from now on, if anyone says that whether this diagram is correct, we are giving AC, we are getting pulsating DC just to a PN junction diode, this is the wrong notation, wrong representation. Without a resistor R connected to the cathode of the diode, we cannot get 0 voltage during the negative half cycle. So the correct diagram would be to place the resistance R, so that during the negative half cycle we can get drop as 0 volts in between this point with respect to this point.